Fusion Mobile, quality e-learning experience on the go.
Still on heat energy, we'll say that volume expansivity is given as the change in volume per unit volume per degree rise in temperature. That means gamma is equal to change in volume divided by original volume and change in temperature. Considering that, we can now move on to still find our formula as we did before, such that delta V will be equal to gamma V naught delta temperature. From here, we can deduce that V2 is equal to V0 will cross over. We have V naught plus gamma V naught times change in temperature. Factorizing out V naught, we have it that V2 is equal to V naught bracket 1 plus gamma change in temperature. But don't forget that gamma is interested in three parameters: length, width, and height. So we can replace gamma with 3 alphas. That means I can rewrite V2 as V naught bracket 1 plus, instead of gamma we have 3 alphas and change in temperature. And this is the equation of final volume. But some textbooks write V naught as V1, so we can rewrite volume as V1 brackets 1 plus 3 alpha delta theta. In terms of units, volume up will go with the volume down, and what will remain there is only change in temperature. So we have the units of V of gamma to be, gamma will now be equal to 1 all over change in temperature, which will be equal to 1 over Kelvin in units. So the unit of gamma is also per Kelvin. We'll now come to expansion of liquids. We have real or absolute cubic or volume expansivity of a liquid. Is defined as the increase in volume per unit rise in temperature. But in apparent, we also consider the containing vessel. Like apparent cubic or volume expansivity of a liquid is the increase in volume per unit volume for a unit rise in temperature when the liquid is heated in an expansible vessel. That brings us to anomalous expansion of water, which make water to expand at a certain temperature, and immediately after the temperature it falls back to its normal size and increases gradually. And that is the major reason why we can never use water as a thermometric substance. Change of states. Heat causes change of states. When you have your water is in liquid state, when you heat it, it changes to steam at boiling rate by the process called vaporization. And when you bring it down from there, it condenses back into water. And when you put it in your fridge or freezer, it chills and gets down to block, which is what? A solid. That brings us to heat transfer. Heat may be transferred from one point to another or from one body to another through conduction, convection, and radiation. I would like us to look at these 3 parameters carefully. Conduction. Conduction is involved when you have heat transfer only, but there is no particle exchange. Example, if I place on your palm a hot electric iron, the heat will be transferred to you, but there will be no particle of the iron that will move into your hand. While in convection, we have both heat transfer and particle exchange. For example, if you want to bath, you bring out your hot water, you don't bath it like that. You pour in cold water to bring the temperature of the hot water down while increasing the temperature of the cold water. At that time, there is particle exchange and there is also heat transfer. But in conduction, we only have heat transfer but no particle exchange. But there is a similarity between these two. Both conduction and convection, there is contact. Before heat can be transferred through conduction or convection, there must be contact. But in radiation, there is no business with contact. We are here and we feel the heat from the sun. We have no contact with the sun. Anytime you have heat without contact, it is regarded as radiation. While when you have heat transfer as a result of contact, you start considering conduction or convection. When there is contact and there is heat transfer without a particle exchange, my dearest, it is conduction. But when there is both particle exchange and also heat transfer, it is convection. The next topic we will handle is electric charges. I hope you are getting yummy for that. We will soon move into a place where physics will be more interesting. Thank you and see you on that class.